Alright, welcome all. This is Kiran Patil, Assistant Professor in Computer Science and Engineering Department, PLDACET, Vijayapura. Now, friends, we have already looked into the two-dimensional geometric transformation. So the same thing will be extended to three-dimensional geometric transformation. As we all know that there are three different types of transformations, such as the translation, we have rotation, and then the scaling. Alright, so first let us talk about three-dimensional translation. As we all know, translation is nothing but the movement of points from one position to the other position. Okay, for example, a position P which is defined with three coordinate values x, y, and z in a three-dimensional place is translated, that means is moved in common statement, in common sentence, we can call the translation as movement. So is translated to a location P dash, which is a new point, okay, which is again defined with the values x dash, y dash, and z dash. By adding translation distances, as I said, we have a translation factors, or we may call it as translation distances. So, such as tx, which is the distance in a line with the x direction, ty, a movement towards the y direction, and tz, a movement which is defined with respect to the z direction or z axis to the Cartesian coordinates of P. So we have new values of x dash defined as x dash is equal to x plus tx. Similarly, we have y dash that is defined as y plus ty. Then we have z dash that is defined as z plus tz. Okay, so this is how the translation happens. Okay, just by adding the translation factor, the translation distances to the values of x, y, and z, we are getting the translation of a point in a three-dimensional space. Right. Now let us look at the homogeneous representation of the translation matrices. Okay. For that, you can see here we have a point P which is defined with the values of x, y, and z. Similarly, the same point is translated or is being moved to a new position defined with the values x dash, y dash, and z dash. Now, if I have to represent this in terms of a matrix, that would be x dash, y dash, z dash 1 is equal to 1 0 0 tx, 0 1 0 ty, 0 0 1 tz, triple 0 1 multiplied with the matrix x, y, z, and 1. So basically, if we are talking about a three-dimensional transformation, then we are supposed to define a transformation matrix in terms of 4 by 4 matrix, or an matrix with an order of 4 by 4. Okay, so basically when you calculate this, when you make the required calculation, you arrive at the you arrive at the previous equation, that is x dash is equal to x plus tx, y dash is equal to y plus ty, and z dash is equal to z plus tz. Alright, so this is a simple example that is given. Alright, so when there is an object again is nothing but the collection of points. Okay, so if that object has to be moved to a new position, then we have to select the points on that object and move that or translate them those points to relevant required position, again which is defined with the matrix T or the vector T. Right. So this is this is the code that we can use in order to translate the points from one position to the other position. Okay, but this is, again, you're well aware of these codes as we have already done this in lab programs. Now let us look into the three-dimensional rotation. Now, when we were dealing with the rotation in a two-dimensional coordinate system, then the rotation would always happen with respect to the third dimension, which was substantially not present in a two-dimensional coordinate system, that is z. Okay, so whenever we are rotating a point or an object or anything for that matter, the rotation in two-dimensional coordinate system always happens with respect to the third coordinate the third coordinate system, or the third coordinate value, that is z, which of course will not be defined in a two-dimensional coordinate system, that is z. Now here, since we have a space, three-dimensional is generally referred as space. Now when we are trying to rotate an object or a point in the space, then it should happen with respect to the all three coordinate values, or all the three coordinate axes. For example, the rotation can happen with respect to z, as you can see here. This is with respect to z. So rotation that has happened with respect to the z axis. Similarly, a rotation may also happen with respect to the x-axis, as shown in the figure B. And then a rotation can also happen with respect to the y-axis. Now, three-dimensional coordinate axis rotation. So how it is defined? Already we know that, when rotation happens with respect to the z-axis, then the equation or the new values of x and y, which is x dash and y dash, are defined as x dash is equal to x cos theta minus y sin theta, y dash is equal to x sin theta plus y cos theta, z dash is equal to z, because of course that's where the rotation happens. That's an axis which has to be kept constant. We cannot change that axis because the rotation is happening about the z-axis in this case. Okay, so again, the homogeneous coordinate form, the homogeneous representation form in terms of the vector would happen as x dash y dash z dash 1 is equal to cos theta minus sin theta 0 0 sin theta cos theta 0 0 0 0 1 0 0 0 1 into multiplied by the vector x, y, z, and 1. So basically, when you perform the calculation over here, you would again end up in getting the equations that are defined above. This is when we talk about the rotation that happens with respect to the z-axis. Right? This is how we can speculate, or we can illustrate the rotation of an object with respect to the z-axis or about the z-axis, where the z value does not change of a point, whereas the x and y value would change as x dash and y dash. Z dash is again equal to z. Okay. Now coming to the other rotations with respect to the other two axes. For example, here in this case, the x-axis. Okay, so what would be the equation of x dash y dash and z dash when we are talking about rotation about the x-axis? So that would be y dash is equal to y cos theta minus z sine theta, z dash is equal to y sine theta plus z cos theta, x dash is equal to x. Similarly, when the rotation happens with respect to the y-axis, then the z dash would have the value, would possess the value defined by the equation z cos theta minus x sine theta, and x dash is defined as, or the value will be given by the equation z sine theta plus x cos theta. Similarly, y dash is equal to y because the rotation is about the y-axis. Here is the diagrammatic representation of different rotations with respect to different axes. Now the first one is the rotation about the z-axis. Similarly, the rotation about the x-axis, and then we have the rotation about the y-axis. Okay. This is the object rotation that is shown over here. So rotation about the y-axis, and similarly the rotation about the x-axis. Alright friends, so this is all about the the transformation that happens in a three-dimensional geometric coordinate system. Alright, I hope this video was informative to all of you. Please like this video if you really like it and hit the like button. Thank you very much. Please keep supporting me.